this quickly. So we have density. Is it a physical or chemical property? So if we want to define density, remember what is density in the first place? Density here, you can say that density here equals, in a mathematical equation, D, I'll say equals density equals mass, so an M divided by our volume, right? So this here is mass in grams divided by our volume. So basically how much something weighs per how much space it takes up per how much space it takes up over volume, right? So when we talk about this concept of physical and chemical properties, remember physical properties. What do we have for physical properties? We have, let's make a list. Actually, let's make a list of physical and chemical properties first. So physical, and then I'll just make like a T list or something like that, and then I'll make chemical properties. So physical properties, what are some examples of physical properties? Feel free to, like, if you know it, definitely chime in on the chat as to what are physical properties. So physical properties, we have obviously texture. Texture is a big one. It's anything you can observe with your kind of eyes, right? Color is a big one. Luster is another big one. For metals, how shiny something is. We have, what else are physical properties? Texture, color. We have like the state itself, right? The state of matter is the physical property, right? State of matter. And yeah, those are just some decent examples of physical properties. And what about chemical properties? Chemical properties are when we try to react it with something, what properties are we using here? So for example, combustibility is a good one. Combustibility, flammability. We have we have other, like corrosive, being corrosive is a chemical property. We have I'm trying to think of indicators of chemical change. So like when it produces gas or if it changes color, these are all telltale signs of a chemical change using its chemical properties. So again, these things are chemical properties. So when we're talking about this topic of density, density is simply just a ratio, right? Like a density of water is one gram per 1 milliliter, right? So does that have to do with any of these physical chemical changes? Does weight, or if I rephrase this question, does weight actually have anything to do with a physical or a chemical property? In this case, no, because weight here can change, right? I can change the weight of water or change the weight of, for example, my water bottle here, right? I can change the weight of this. I can buy a smaller water bottle or something like that. But can I change the texture or the color or the luster or the state of matter in this case? In this case, I can't, right? If I want to buy the exact same bottle in a different size, I could. Or but in terms of color, it would change the actual the physical property, right? Because if I look at it, it's a different bottle, right? It's a different bottle in terms of the color. So if you think about it, in terms of density, we're talking about density or even weight, how much or the mass of something. It's neither a physical or chemical property because it's an inherent quality of the material itself. So it neither belongs in physical or chemical. It's actually I guess you can say it's not somewhere in the middle, but if anything, it kind of leans towards this physical property side. But density isn't really it's not physical property that we use to describe something. When we're describing physical properties of something, what we do is describe the texture, the color, the luster, the state of matter. We don't use weight because weight can change. Whereas texture, color, luster, and state of matter can't change. Copper will remain copper. It will remain hard, gold will remain brittle. Gold will remain shiny unless a chemical reaction happens. And the state of matter doesn't change unless I change the temperature, right? So again, these are things that don't change unless I change another thing. Density doesn't change. So in this case, they kind of describe what a physical and chemical property is. That's good. So they're calculating some density of the matter here. So they kind of use this mathematical explanation to figure out the density of an object. That's okay. So I'm going to say density is the ratio between mass and volume, which has nothing to do with the change of state. Neither mass will be changed under any physical process, or will volume be affected. So it can be stated that density is a physical property of the matter. So personally, like I don't like this answer because, again, it's definitely not a chemical property. So we can say that it's definitely not a chemical property. When we talk about physical properties, it's more so has to do with like what you can see with the property, because I care about what I can see, what I can feel. Again, taste would be a physical property, but we don't use taste in the lab. That's kind of the realm of physical properties. So I would say the density is, to be really precise, I would say density is actually neither a physical or chemical property, because it's an inherent property. But I see the logic in terms of what they're trying to describe, with density being a physical property, because it's something that's that takes shape and takes form, but then can also change depending on if I add more of that substance here. So I'm going to say that solution is, I'm gonna say I see the logic behind the solution. However, density does not. Let's see, density. Neither mass will be changed under any physical process, or will volume be affected. So you may say that density is a physical property. However, density is an inherent property of any substance. So it can also be said that it is neither or chemical property. However, if I had to choose between physical or chemical, I would also say that density belongs or is a physical property. There. Okay, so that's question 2.